I'm actually really excited that I get to do this talk today because I did this talk in Phil Bangalore and it was not recorded. And so now we get a version that can end up on the internet as well and hopefully help some folks index. I've also updated it, so it even got a dry run. It's perfect. But excited to welcome folks and do kind of an overview introduction to Filecoin. This is going to start from before Filecoin was a thing, it was just an apple in the eyes of the Web3 community when Filecoin was just getting started, through kind of where it exists today with the storage and retrieval lifecycle, the different implementations that exist, the many different sub-modules and tools that are helping serve different needs within the Filecoin ecosystem. And I think that's what I get through, but I'm also happy to take a lot of questions. I'm going to try and go faster than 30 minutes so that we get time for people to dive deeper in different areas. Okay, so first, starting out with the mission of Filecoin, which is to create a decentralized, efficient, and robust foundation for humanity's information. And each word in there is very important and chosen specifically to orient Filecoin towards solving critical problems that can increase the kind of digital human rights that we as a society can depend upon. Decentralized means that it's not reliant on any one institution, that no one, has the backdoor keys to, manage or control the system. Efficient, we want to enable a more efficient system for storage. Robust, data that is stored in Filecoin is robust and checked and verified over time. Foundation, it can be a foundational system that many people build upon. It's open access and constantly improving, kind of from a foundational level. And then it is oriented toward and serves humanity's information, the critical data that we are creating, generating, and kind of building upon over time. And if you want to read more about each one of those, the FIPS repo has a great page that kind of has bullet points and describes what success looks like. We are not yet at full success of all of those mission points. We still have a long way to grow as an ecosystem, but it kind of envisions and shares why each of those missions is important. So where did we come from? Where did Filecoin start? So maybe some of you very, very OG folks were in the Web3 ecosystem back in 2008 when Bitcoin came on the scene, started doing programmable money, proof of work ecosystem. Then you had Ethereum come on it launched in 2015, adding smart contracts, adding the kind of EVM system for launching applications. IPFS also launched in 2015, creating this content-addressed peer-to-peer file system. And Filecoin was building on those early ideas and kind of innovating, where it was taking the proof of work from Bitcoin and applying it to a useful resource, which is using it to kind of verify the storage and capacity of storage resources in the Filecoin ecosystem through the proof of work job of Bitcoin. So back in the day, this is still pre-proof of stake movements. And so lots of the critical blockchain networks were proof of work, and Filecoin was great, we're going to take that, we're going to do useful proof of work, applying it to checking and verifying storage of files over time. And so here's the Filecoin white paper that I think there was an earlier version even before this, but this is kind of the updated one from 2014. Again, building upon a lot of those kind of critical, baselines from Bitcoin, doing this proof of work and proof of retrievability so that you could be checking that nodes are storing a particular file over time, and then creating this kind of incentive for robust storage and having an immutable kind of view for the ecosystem to see the data that's stored. And this is all part of the kind of Web3 movement of read, write, trust. So many of you probably, when the internet was first getting started, you had wires, you had a network, and then Web 1.0 ended up with lots of websites and scientific documents getting published, and it was kind of static content. Web 2 was a very exciting innovation upon that, where it was read and write. You ended up with marketplaces, social networks, and Web 3.0 aims to bring trust and verifiability into the interactions between these applications, so that instead of trusting these kind of centralized kind of walled gardens, you can trust the infrastructure that you are building with directly, and you can embed verification into the kind of interfaces between these applications or into the visibility of the application itself. Filecoin is also part of the kind of wider PL movement of having digital human rights. So being able to have secure data publishing, secure networking, data storage and sharing, decentralized ability to kind of connect and transact around data and applications. And a lot of these, aim to map to some of the key human rights that we want to see embedded in the world in general. We want to bring these into the kind of like core infrastructure that we are building within the internet and that all of our kind of like applications and superpowers depend upon. Okay, so Filecoin also here is building upon many different building blocks. IPFS was created first. It's like a peer-to-peer file system for storing data. It benefits from content addressing. So every different piece of content in IPFS has its own little digital fingerprint. And files are exchanged between anyone who's hosting the content by that content address instead of having to go to one particular location and not being able to verify that the content is what you care about. libp2p is the peer-to-peer networking layer that's used by IPFS and also powers Filecoin and many other blockchains like Ethereum and Polygon and Celestia and 10,000 other ones. And then Filecoin builds on both of these areas to then add an incentive for data storage and data persistence so that it's building upon these content addressing libraries and ways of storing data and using libp2p to exchange and interact between nodes. And then Filecoin for adding, great, here's some fill, please store this file for me for this period of time. And then the network is able to track and verify that that's happening as we go. All right, so I'm going to now walk through, again, if you're familiar with Filecoin, this is probably going to be a bit repetitive, but an overview of kind of like how the Filecoin system works and the different kind of players within that space. So Filecoin actually means multiple different things in this overall diagram. It's both a decentralized storage network. It's a series of decentralized storage protocols for interacting within that network. There's a payment mechanism, Fill, which is used for paying for storage in the Filecoin ecosystem. And it's also this ecosystem of many different builders, players, applications, developers who come together and work together. So we have kind of three main roles, at least in this part of the diagram, of folks who are interfacing with the Filecoin protocol in the Filecoin network. We have clients who want to store their data. We have storage providers who provide storage, well named, and then the network itself, which is managing the kind of market and interflow between these different roles. So the network acts as an intermediary when clients want to store data. They can put up some, fill amount, and then can be an intermediary that is acting between clients and storage providers. The network is then also what is checking over time that storage providers are continuing to store the data that they have committed to the clients and collecting proofs at every 24 hours, which is the epoch we use right now, that data is still being stored correctly. And the network is also then paying out storage providers over time. That can be either based on the block rewards that they are earning from the network or based on the kind of like payment amount that a client put at the early stages of a deal that can then be paid incrementally over the lifetime of that deal. And so both clients and miners need to be able to trust that the network is able to do those things. For that, we use ZK snarks. If you're not familiar, there's actually a great website with live statistics about how Filecoin is, I believe, still the snarkiest network to date, with tons of ZK snarks being run in every single epoch. So yeah, we talked about these three roles: clients who want to store data, storage providers, and then we also have this much wider ecosystem of developers and ecosystem partners who are building different technologies that are serving different parts of the Filecoin network. Another piece of the Filecoin ecosystem is the Filecoin Plus program. If you're really interested in that, there is a talk on it upstairs. And this creates an incentive for storing data in Filecoin. So this is about attracting humanities information and helping Filecoin compete with incumbent large-scale storage providers like AWS to bring data to the Filecoin network and make it more valuable to store useful data in Filecoin than to have kind of empty capacity that isn't being put to work within the Filecoin ecosystem. And there's a great talk on this from the, 2 PhilDev summits ago, the one in Singapore, on like why humanities information, why have there be an incentive for bringing data to the Filecoin ecosystem. It's so that, this graph here, that when in the early days, you're trying to compete against an incumbent, you need to be having an attractor, very strong attractor into your ecosystem, because you don't have the feature set or capability that is comparable to those incumbents. So you need to bring people, and then you can grow over time, such that you become, instead of the early kind of like more nascent user, the incumbent yourself, and then someone else is trying to compete you and attract users away from you in the future. And so this is the graph for the cloud going from 1990 to today, where the cloud came in as the place that people were migrating from on-prem services, and it offered a significant discount over working with on-prem services. And now actually you can get cost savings by migrating from the cloud to on-prem, because over time it has grown as an offering, and it's increased its prices and it's increased its capabilities, so that it's now able to charge a premium over top of those sorts of on-prem distributions. So a little bit about how Fil Plus works. The process here has a data client who can request data cap from a notary. We're actually now calling these kind of allocator programs. A notary might be a participant in an allocator, but there's multiple different kinds of allocators. Some of them do automatic verification. Some of them have a kind of like party that's doing KYC over the people that it allocates data cap to. Some of them just allocate data cap to anyone who has a GitHub ID. Some of them, we actually have like, I think 50 plus new allocators, like a number of which are experimenting with new verifiable ways of doing data cap allocation. And so your data cap client can work with one or multiple of those allocators, receive some data cap, which is a kind of NFT in the Filecoin ecosystem, which it then applies to a deal that it is making with a storage provider. And that then gives the storage provider a multiplier on their block rewards when they store those pieces of data in the Filecoin ecosystem. And so that reward incentivizes the storage provider to do the extra work of onboarding client data into the system versus just having an empty sector that doesn't have any useful data in it. And so that is and this website actually allows you to toggle back and forth, so you can see what it looks like when you don't have any data cap in there. Probably going to skip this part, but this is just kind of breaking down some of the different steps in a Filecoin storage deal. That was a nice diagram. You have clients who make these limited time deals. They transform their data into a content-addressed DAG, directed acyclic graph. So that's using all of that IPFS and IPLD data models. They then send that data to a storage provider. The storage provider makes an initial proof that they are putting that data into a sector. They do a chunk of kind of, somewhat compute-intensive work to seal that data into the Filecoin network. And then over time, every 24 hours, they have to do a new proof over that data that, yes, I'm still storing this data. It's still here. And so you get every 24 hours these kind of like proofs that flow into the Filecoin blockchain. POREP, proof of replication, is the first one. This is like the more intensive one. And then post proof of spacetime are the ones that happen every 24 hours, where they're, that particular sector of data is getting sampled. The storage provider is still storing it over time. And then at the end of the deal, the storage provider can terminate that sector or replace it with new data or something like that. I kind of mentioned these two main proof types. Proof of replication is that one based on sealing upfront. And then proof of spacetime is the one that happens kind of repeatedly every 24 hours. And you have a limited amount of time to respond to a challenge that shows you're still storing the data. Cool. So how does this all fit together in the Filecoin ecosystem? And let's overview some of the different tools and components that make this up. So if you haven't seen this before, this is the storage and retrieval lifecycle for Filecoin. See if I have a mouse. Yeah. So you have storage clients. These are people who have data that want to store it. Many of these work with different on-ramps that are working in kind of like different kind of like strategies, or work with different types of clients, different scales, different speeds, different sizes of data. Those help kind of smooth the experience of working directly with storage providers. Some storage providers run their own on-ramps, so that can be a smooth experience as well for working with some specific groups. On-ramp storage providers and retrieval providers all work with indexing, making sure that the data that's being stored in the sector has an index and can then be kind of like accessible or retrieved from whoever's storing it. retrieval providers can also act as kind of like a cache layer on top of data that's requested frequently. So you're not, going back to storage providers over and over and over again. And then you can have retrieval clients that might be requesting data to load a web page from, say, like the IPFS gateway or something like that. So there's kind of two phases here. You can store data and you can retrieve data. There are a ton of different on-ramps right now. Many of these today are still kind of like Web 2.5, if you will. They're, groups that have built a storage interface that offer something that feels like a Drive UI, or offer something that has like smooth developer APIs and is kind of handling the aggregation and orchestration for you. There's work in progress, and if you're interested in this, go into the room next door, working on making decentralized on-ramps that are utilizing kind of like L2 networks of nodes that perform things like data transformation, data aggregation, and kind of onboarding with storage providers on behalf of clients, so that clients don't have to do all of that prep work and they don't necessarily have to rely on one central on-ramp. Cool. Here are a couple of examples. There's NFT storage, which is targeted toward the NFT community, has a ton of users who've been using that for the past couple of years, and has great developer APIs. Really easy to use if you are an NFT creator and you don't want to think about what is happening and you just want a super simple upload flow. There's some kind of like large data-oriented ones, like the work that was done with the dstore REST API that's kind of offering an integration pathway for kind of these like larger storage backup systems. There's Lighthouse, we've named it here, who's building kind of like the kind of perpetual endowment version, and they have a lot of FVM smart contract APIs as well for you to upload your data to Lighthouse, and Lighthouse can then aggregate it and orchestrate it into storage provider deals. On the storage provider side, this is where you have nodes in the Filecoin network that are running one of the three main Filecoin implementations, Vetus, Lotus, and Forest. There's also the Boost node that acts as like a market node where it's taking storage deals and giving storage providers a way of like tracking all of the different kind of inbound deals they're getting from clients. So Lotus was the first of these that went live. First Filecoin client has a number of different kind of modules within it. It's written in Golang, maintained by the Lotus and Philos team, and has a number of different kind of subcomponents in here. Workers that are kind of doing proving and sealing, the Lotus miner, which is doing some scheduling, the daemon, which is the thing that's kind of interfacing with the chain and wallets and other things, and then Boost, which is this market node. There's Venus, which has three different components. It has kind of a storage cluster for maintaining storage power. It has Droplet, which does the deal making and market side of things, and then Sophon, which is kind of around node scheduling and services and syncing. And then Forest is the only Rust client. Both of the other two are written in Golang. Forest is all Rust-tastic, maintained by the ChainSafe team. And this one's really been optimizing for chain infra services. So they're the ones right now who are running the snapshot service that lots of folks use for kind of minimizing the amount of overhead in their node infrastructure so that they don't have to store a lot of historical chain data that's no longer relevant, and helps people sync and join the network faster when they're first bootstrapping. They also, I think this might now be live, that they now have bootstrap nodes running on both the calibration net and mainnet, and are offering some useful RPC APIs for people to, fetch chain history and data, and doing all of that with like a very lightweight, efficient Rust client. And then there's Boost, which is the markets node that has this, handy UI on it that allows you to, both as a client, publish storage deals, or as a storage provider, like manage and see the deals that are flowing through. It also allows you to, index and serve the data that you are fetching over multiple different retrieval protocols. So you can retrieve via HTTP, GraphSync, or BitSwap. And BitSwap is useful if you're connecting to things like IPFS nodes or IPFS gateways as well. There's this network indexer, which we call IPNI, the Interplanetary Network Indexer, which is what all of these different groups are publishing their indexes to, so that you can efficiently go to the indexer and be like, great, I want this particular file. who has it, where is it, and the indexer maintains those records, and it'll tell you who's publishing it, over what transport, and then you can go and connect directly with that node and fetch the data from it. But it's super useful, very large, it has indexed a ton of data. This was kind of a next step beyond utilizing the kind of like IPFS public DHT, because DHTs do not scale to the 2 exabytes of data that are now stored in Filecoin. And so we needed a much more scalable indexer that was going to be more efficient than trying to gossip the set of provider records every 24 hours for exabytes of data. It just wasn't gonna scale. And there's a number of different groups who run nodes of the network indexer, and they use libp2p to kind of stay in sync with each other. We also then get to retrieval providers. Some of these are networks that are playing slightly different roles here. There's, of course, the IPFS HTTP gateway, which has been kind of a interface to fetching content from different kind of like IPFS Kubo nodes or the Filecoin storage provider nodes, so that you can, just directly from HTTP or via a website that isn't, enabled with any Web3 technology, be like, great, I'm going to fetch this site. There's also this project called Filecoin Saturn, which has been building a lot of the building blocks for content retrieval. And so they have a number of nodes that have been built up as a kind of layer 2 network that are, caching content and doing the fetching process from storage providers when they want to, when someone requests content from them. So they act as retrieval providers. Station is this worker node that many people might be running. It gives you microfill for every transaction you do. So I think I'm almost at 0.1 fill in the past couple of months that I've been running this. But effectively, anyone can, on their local laptop, can run this. And what's happening in the background is it's doing retrieval checking in the Filecoin ecosystem to see, are the pieces of data that have been published at the Interplanetary Network Indexer and stored in Filecoin storage providers, are they accessible? Can you retrieve them? And then it logs that data, and that data set is a public data set that then can be utilized by things like Phil Plus allocators to be like, great, you said you were going to make this data retrievable. Is it actually retrievable? And create a kind of reputation system there. And then, of course, there's retrieval clients. We'd mentioned there's the IPFS gateway. If you go into Brave and you use Brave as your browser, you actually have an embedded IPFS node right in your browser that is doing retrieval requests for you. There's also Lassie, which is a retrieval client for doing retrievals that's used by Saturn and I think a couple of other groups. And then, of course, there's a really exciting thread around interfacing and bringing compute into this system. So there's some projects that are kind of sitting next to storage providers or like that are aiming to cross-connect the data that's stored in Filecoin sectors with the kind of compute jobs that you want to run over that. And then, of course, feed them back into new storage sectors, feed the output back in. So there's a couple of different projects. There's Zama that's doing fully homomorphic encryption, Lurk that's doing kind of more like private verifiable compute jobs, and they have like a specialized language for it. There's IPVM, which is using Buckliao to try and create like kind of like low level kind of like IPFS like compute jobs, I guess. That's kind of at the atomic level. And then there's a lot of other projects in the compute space, and there's going to be an interesting track maybe in here in the afternoon, I think, specifically on compute APIs to data stored with Filecoin. Cool. So I think that's all my content, and it's good because I'm over time. But if this is new to you and this is exciting and you want to go get involved, there's a couple of really useful first steps. There's this program called Launchpad that created a whole ton of getting started tutorials and curated a set of videos that are really good for learning about how Filecoin works under the hood. I'll stick up a QR code to these slides in a hot second. And so that's a great place to get started. You can watch those deep dive walkthroughs of like how the protocol works and what's happening under the hood. There's a set of contribution guidelines on GitHub that kind of help explain if you want to start making a pull request or making suggestions, how to structure that to best enable others to review and participate. There are these kind of like good first issue tags, and I think there's a help wanted tag. Yeah, help wanted as well. These tags are in various different repos in the Filecoin project to highlight areas where you can start contributing, or a good place to like pick up a project and make a desired contribution. There's also the Phil Lotus Dev Slack channel, which is a great place to ask for support or be like, great, I'm going to try working on this. Help as I go through it would be useful. We're friendly humans. We will happily jump in and help you through that. Make sure that as you go through things, you ask for reviews, you respond to feedback, write tests, make sure it's working, and then come and meet people in person at these sorts of gatherings. It's a great place to kind of build relationships with other devs and build your expertise on these future projects as well. So a couple ideas. But yeah, with that, I'm happy to answer any questions.
With this thing,
I will tweet it. So follow me on Twitter and I'll tweet the link to these slides, which are open slides, but I guess not yours. I have another deck that is already open and shared. And so I'll tweet that, and I'll also stick it in the Slack, the SilDev Summit Slack channel. And feel free to ask other questions as they come up too.
Are you going to use Filecoin for slides, or?
Am I going to use Filecoin to store slides? I definitely can. That's a great suggestion. I'll use I can put it two places, which is ChainSafe Files and Web3.storage are both ones that I use for storing random things and have nice little Drive style UIs and have nice free tiers so that you can just get started dropping your slides. Good suggestion.
A bit more technical to part. How does what you mentioned station
Yeah, hi. Two-part question. What role does station play in the network? Is it basically the source of requests for the proof of space-time, or is that the proof of space-time is sort of a systematic request, and this is basically sort of an added layer of metadata that's being collected?
Yeah, so the proof of space-time is happening over a sealed sector. So we've done kind of a somewhat compute-intensive process over top of the data that was originally stored in Filecoin, so that we can do very efficient proving, and that you can't say take 3 storage deals with the exact same file and then only store one of them, but pretend that you're storing 300, 3,000, 3 million. So it makes every copy totally individual, and the kind of core implementations, Lotus, Venus, Forest, those are the ones that are facilitating that proof of space-time over top of the data that's been stored in Filecoin. So that's happening at a core implementation level. What Station is doing, I am not running a storage provider node. As cool as I am, my poor laptop probably would not have the amount of storage needed to do that. I do run a Lotus node every now and then, but it definitely is a little bit more power hungry. Station literally runs in the background. It is like a tiny little kind of like side application that you run. And what that is doing is it's making, I believe, HTTP lightweight retrieval requests to storage providers and trying to test, hey, is this data that you stored retrievable? And Filecoin, the core Filecoin protocol is saying, it's proof that you have this data, but actually none of it is retrieved by the network. It's a local proof that is happening on a storage provider machine that they can't fake, but that doesn't put that data into the Filecoin chain, so it's more scalable. And so Station, on the other hand, is doing these like small micro retrieval transactions, little range requests to be like, cool, can I actually get the data from you that you say you're storing? And so it's serving a different purpose, but with the aim that you can then feed those retrieval logs that are happening from a global, there's like 13,000 Station nodes now, which is kind of insane. It's only been around for like 2-3 months. But it's a whole global network. Anyone can spin up a Station node, run it on whatever device they want. And then we can embed the logs from that into, say, the Filecoin protocol and change and embed retrieval incentives back down into Filecoin. Because right now, Filecoin, natively at the protocol level is just a storage retrieval or a storage incentive market. It doesn't have retrieval incentives baked in. Is there a second card?
No, that.
Okay, cool. You want to grab them?
So you know how with Bitcoin, the miner side, like the supply side over the years has become very competitive and very like industrialized from maybe the beginning stages of like retail participating. So what's like the current state of the storage provider, the supply side?
Yeah, it's a great question. We definitely saw, even in the early days of Filecoin, like very large scale and pretty professional storage providers joining the Filecoin ecosystem with like large data centers of capacity. I would say it's definitely, there were also, on the flip side, folks who were running it in their own basement, cooling, using it as like a heat generator for their flooring system. And there's a great video about this on YouTube with, I think it's Benjamin. Yeah. Showing how he's connected it into his heating system in Denmark. And so a lot of those folks who got involved really early are now like the expert consultants that work with even larger scale storage providers. But I would definitely say like, the level of professionalism and like, these are folks who are offering robust, reliable infra services. There's a kind of more of a commitment when you join the Filecoin network of like, I'm going to store your data robustly and I'm going to commit to doing that over time. Whereas Bitcoin miners are a little bit like plug in, plug out, like I'm here for a second and then maybe I'm mining Litecoin or I'm mining Ethereum the next day. So Filecoin storage providers, I think, are a little bit more service oriented of like, we're actually offering a robust service. And there's definitely, over top of the most recent bear market, I think been some amount of kind of consolidation, and groups that are the most efficient groups have grown and been able to kind of harness more resources through that. I definitely think there's still a benefit to being very like, understanding the protocol very deeply. The groups who have invested time and energy in that, I think, at least my perception is that there's some growth. You can also talk to James, who used to be a Filecoin storage provider, maybe even still runs a node here and there. Amazing. Perfect. So there's definitely kind of space across that, but the largest storage providers are like, 10, 100 person large scale like companies.
Like it's market, like all the market,
We've talked to them a little bit. I think they're more interested right now in selling services to storage providers. But definitely the long-term vision for Filecoin is like, great, like here is a decentralized marketplace where GCP and AWS and these other infra providers can compete on an even playing field, and you can hold them accountable in the same way that you would hold some storage provider in Germany who's storing your files there, accountable for actually keeping your data accessible, and you can have a marketplace that includes all of those providers as well.
Is there a conceptual model of the nodes? So the ecosystem model was fantastic, but then on the right, there was all the different
Lotus, Venus.
That the nodes are running, and so where the sort of chain resides, and sort of what else, the different components and how they all fit together within the node, within a storage provider, in terms of looking at how that might be segmented.
Yeah, I know James actually has created, I think you and Orion have created some diagrams of the Lotus node in particular. Obviously, each one of these looks slightly different, what the architecture of each node looks like under the hood. Like at a network level, I think we have, like Forest is a relatively small percentage of the number of nodes, but are backing some pretty significant infra services. Lotus is the vast majority of the number of nodes in the network, but I think Venus has now grown to be about 20% of QAP, which is the quality adjusted power of the network. And so, it's a pretty significant thing that's happened in like the last 6 months. So some really awesome growth there on the Venus side. And I was kind of trying to explain, if we go back a bit, like, here's a very lightweight architecture diagram. I think you have more intense or more detailed ones of kind of what Lotus breaks down. And then these are like the 3 main modules in Venus that interface with each other. But I don't have a great architecture diagram of Venus. And so I think those are good questions. And I do think it would behoove us and benefit the ecosystem to have like, a better exactly of how they're evolving over time. But yeah, talk to James, and James, if you can share that out of like, because you have some good ones, and I think there's a deeper dive talk specifically on the Lotus architecture and how it's changed over time. But I don't think I quite have that diagram for Venus right now.
Do you mean? So it's here. Yes, when we were talking about the IPFS, the widely coupled. So it seems that when we are mentioning IPFS, that it is tightly coupled to Filecoin network. Is it so, or you can use IPFS on its own?
You can absolutely use IPFS on its own. Like the way we think of it is like Filecoin is a subset of IPFS. You can absolutely use many different parts of IPFS without using Filecoin, but Filecoin is literally underpinned by the same peer-to-peer transports, the same data model. Like when nodes are, the Lotus node is an IPFS node. It's just a very specialized IPFS node that takes payment in fill for the storage that it is doing in the system, and it, then serves the data that it is storing, if it's keeping unsealed copies, to other IPFS nodes of different types that might be requesting it for content. And it doesn't announce its content to the public IPFS DHT, which is what's common for many IPFS node types like Kubo and Helia and a number of the other ones, and it instead uses the interplanetary network indexer because it's trying to account for, hey, I might have like tens or hundreds of petabytes of data on a single node. And so announcing that content would be too cost prohibitive, like too much bandwidth and just too much like traffic for me to do within a single day. And so you can absolutely, and there's many groups that are, like there's tons of blockchains that are IPFS based. Blue Sky, the Twitter, decentralized Twitter version is using the same data model as IPFS. It's not quite doing peer-to-peer connections, but I think someone could augment it with that over time. And so there's lots of ways of using IPFS. It's a much broader ecosystem. Filecoin is specifically applying this network of kind of incentivized transactions for storage to that same kind of like set of core primitives.
Yeah, we always wondering to ask that question. So just to be clear, the Kubo client, so the decentralized client.
When I'm retrieving a file through Kubo, I'm only querying via libp2p all the other Kubo clients. I am not in contact with a Lotus client and all the files that the Lotus client has backed up through Filecoin. I need to use something like Boost to retrieve that?
Actually, no. Kubo does query the interplanetary network indexer, and it can find content that is being announced by a Filecoin storage provider that's available over BitSwap. I don't think, though I might be wrong, there was some work in progress. I don't know the latest state of it for Kubo to also fetch content from, say, like a Boost or Lotus or Venus node over HTTP, which more, there's a small number of storage providers that are announcing and sharing their content over BitSwap right now because there's just been minimal demand. It's in Boost. You can enable it, but you don't have to enable it. It's not required. So for a Kubo node, we're not going to the IPFS side of things, but I spent a chunk of time in the IPFS ecosystem and love them dearly. When you make a request in Kubo, the first thing that you do is you ask all of the peers that you are currently connected to, hey, BitSwap want have, I want this file, do you have it? And that kind of queries specifically the nodes you're connected to. If no one immediately responds being like, I have, sounds great, then you query the public DHT and you say, hey, DHT of nodes, key space of the DHT, who has this content? Find me a provider record. And so you then do your DHT search through multiple different nodes that are participating as servers in the the IPFS public network to figure out, okay, where's a provider record? And then you can dial that node directly and be like, cool, I saw from the DHT that you have this content, give it to me. Kubo, not all IPFS implementations, but I believe Kubo also does, in parallel to that, a request to the Interplanetary Network Indexer and is like, hey, what are all of the provider records for this CID? And that's a lot faster than making a DHT query, especially if your DHT is large and you have hundreds of thousands of nodes participating in the IPFS ecosystem. So like, that's why IPNI was created, was to be a much faster way to query a very large key space. And so it does both of those. And if it finds a provider record that is being served by a, for example, Magic, who's a member of the Philos team, runs a storage provider that's serving, tons of content from his particular node, that would show up in Interplanetary Network Indexer. You would dial that and you would fetch the content directly from that storage provider node. Yeah. Awesome. I'm way over time, but this is my favorite thing. So if anyone else has further questions, I'm going to stick the slides and all of the links to next steps in Slack, and I'm going to tweet it. And then if anyone wants to find me at any point throughout here, I'm really, really happy to chat, answer more questions, direct you to much more knowledgeable people than I. Dean is an even better person to ask these questions to, because I might be out of date in my understanding and knowledge. But it's been really fun chatting with you guys, and look forward to more.